Today we're going to go over reference angles and not only what they are, but how we find them. So first and foremost, reference angles are used to determine how far away our angle is from the x-axis. Reference angles are always positive because you're talking about distance. So we're saying this angle is 10 degrees away from the x-axis. This angle is 5 degrees away from the x-axis. So they're always positive. And reference angles can be in radians or degrees. Okay, there are going to be some important angles that are going to be helpful for you to know, as well as we'll identify what the quadrants of our graph is for each of the reference angles. So for example, since this side is where we always start off, right here, let's make it a that's always our initial side, right? And so we would say, oh, I want to do that in a different color. Maybe not quite as wide either. Okay. So there we go. That's our initial side. And so we would say that that is angle 0 degrees or 0 radians. Okay, so if you didn't measure from there at all, if your angle didn't go up or down, we'd say it has 0 degrees. Now, another important angle for you to know is if we're looking at positive angles specifically, so we're going to be going this way around our quadrants, would be up here at the very top. So if I go a quarter of a circle, this would be 90 degrees, or in radian measurement, that would be pi over 2. Okay. Over here, if we do a full half of a circle, then we would get 180 degrees, or in radians, that's just pi. You'll notice that this looks pretty familiar. That's our conversion factor, right? That's what we use to determine, or to convert degrees and radians back and forth to each other. So that's 1/4 of a circle, 1/2 of a circle. If we do 3/4 of a circle, we'll end up with 270 degrees, or 3 pi over 2. I should probably do 3 pi over 2. It's the radian measurement of that. And then if we go all the way around, if we make a full circle, so we'd end up at 360 degrees again, or 2 pi radians. Notice I only had to write radians when I wrote the 0 because 0 doesn't have any pi, so it should be indicated whether you're talking about 0 degrees or 0 radians. But these other pieces, pi over 2, pi, 3 pi over 2, and 2 pi are all have pi in them, so they're all indicated as radians. The other thing that will be helpful when looking at reference angles is to know your quadrants, and we hit the quadrants in the same order that you draw positive angles. So this would be considered our first quadrant, and so we mark them with Roman numeral 1. Our second quadrant over here is quadrant 2. This is our third quadrant, and then our fourth quadrant. You can think of it as a C, and that's the order that they go in, C for calculus or C for crazy. It's up to you, but the way in which we draw positive angles, it follows quadrant 1, quadrant 2, quadrant 3, quadrant 4, okay? And so it'll be helpful to know those when we are looking at reference angles. So for finding reference angles, there's basically 3 steps you have to find or have to do. And if this one is you only have to do it sometimes. So if the angle is what we would consider too big or too small, that is, it doesn't fit between 0 and 360. Right? Because our normal quadrants go from 0 to 360. So if we have an angle that's like 924, or if we have an angle that's negative, like -10, those angles would be considered too big or too small to do anything with. And so what you would have to do first is find a coterminal angle. We learned about those previously. A coterminal angle that fits between 0 and 360 degrees, okay? Or between 0 and 2 pi. After you do that, we find out which quadrant the angle lies in. So it's either in quadrant 1, 2, 3, or 4. And then you have to find the difference between that angle and the x-axis. Now notice on here your x-axis, we're really only going to be dealing with this piece right here. Let's see if I can make another line. Right, so this is my x-axis. And so basically what we're going to be looking at is we're going to be finding angles that are in quadrant 1, 2, 3, or 4, and then figuring out their distance just from that x-axis, okay? All right, so let's do that. All right, so we're going to find the reference angle for 28 degrees. So it's helpful, first, I usually always do this, so I'll draw a little mini section here. 28 isn't too big or too small. It fits between 0 and 360, so I can skip step number 1. Now I have to find out which quadrant the angle lies in. So 28 degrees is it falls between 0 and 90, so it's in quadrant 1. So I usually just draw a little line. It doesn't have to actually be at 28 degrees, but I'm just remembering that it's in quadrant 1. And then I have to find the difference between 28 degrees and my x-axis. So what you're essentially finding is you're finding this angle that's right here. Here, let's draw that a little bigger. Right, so here's our 28 degrees, and my reference angle is the difference between that angle and the x-axis. So this is at 28 degrees. That x-axis measurement is 0. So when I do 28 minus 0, I end up with 28 degrees. So 28 degrees is actually its own reference angle because that's how far away it is from the x-axis. Now let's look at 123 degrees. So first of all, you check, is 123, does it fit between 0 and 360? Correct, so I can skip step 1. The angle's not too big or too small. So I'll find out which quadrant 123 is in. And so 123, let's see, falls between 90 and 180. So I'm just going to draw, again, it doesn't have to be exact, but I know it falls somewhere over here. So there's 123 degrees. And now I'm finding the difference between 123 and my x-axis, which is over here. And so I'm really finding the difference between 123 and the next closest x-axis angle, which is 180. And so I'm finding the difference between 180 and 123 degrees. So I can subtract them. And then I would get, what's that, 57? Beautiful. So 57 is my reference angle. A lot of times students get stuck as to whether to subtract them this way or to do 123 minus 180. One way around that is to remember that your reference angle always has to be positive. So if I had accidentally flip-flopped these two, I would have ended up with a negative angle, and I would have known that I'd done it wrong. All right. For radian measurements, my recommendation, just because we probably don't feel 100% with like adding and subtracting fractions and getting common denominators and in general. So let's go ahead, and I still want my answer to be in radians, but this will be some good practice as well. What we're going to do for radian problems is you're going to convert 2 degrees first, then convert back at the end. Because we're usually better at identifying or working with degree measurements. So convert 2 degrees to start off with, and then we'll convert back at the end to find our reference angle in radians. So let's do that first. This is good practice anyway. So 7 pi over 4. If I would like to get rid of the radians, I got to put radians on the bottom. And then pi divided by pi cancels, so I'm left with 7 times 180 divided by 4. You can hear me getting out my handy dandy calculator. Okay, so this is really 315 degrees. And so now I'm going to work with that angle instead. So if I draw, it's between 0 and 360, so it's not too big or it's not too small. 315 degrees is more than 270 and less than 360, so it's over here somewhere. Whoops, not an arrow. And so then now I'm finding the difference between that angle and my x-axis. So I'm finding the difference between 315, and then the next closest x-axis piece is 360. So then I'm going to do 360 degrees minus 315 degrees, which gives me, what's that, 45? And so that's my reference angle in degrees, but because I started with radians, I want to end with radians, so my last step would be to convert back to radians for my final answer. So pi we don't actually put into our calculator because it'll give us a gross decimal, and then you can do 45 divided by 180. Math, enter, enter to find the reduced fraction form of that. Math, enter, enter. Me. Yes, I'm a fool. It's fine. Here you go. And so then now we found that this is 1 pi over 4, so my reference angle is pi over 4. Cool. All right, let's try the next one. So in the next one, we got 5 pi over 3, so I'm going to follow the same sort of setup we got going on here. I'm going to convert it first to degrees so I can actually work with it more easily. Okay. Pi's cancel. 5 times 180 divided by 3 is 300 degrees. 300 degrees falls in my fourth quadrant. And then I'm finding the difference between 300 degrees and 360 degrees, my x-axis. So I do 360 minus 300, which gives me 60 degrees. And then last but not least, I need to, let's do a little squiggly line here because we're doing conversion, so I want to do those in red. We're going to convert my 60 degrees back to radians. So then I'm going to do pi, wow, that was a gross pi top, over 180. Again, we leave the pi out of our calculation because our calculator freaks out. 60 divided by 180, math, enter, enter, and we get 1/3. So our reference angle is pi over 3. Beautiful. All right, we got 2 more. All right, so this one's already in degrees, so I don't have to convert it at all, but it is too small. So this is where step 1 is going to come into play, where I first have to find a coterminal angle that's between 0 and 360. So negative 865 is too small, so I'm going to add 360 to it. Negative 865 plus 360. All right, that's still too small, so I'm going to do it again. That's still too small. Let's try one more time. 215 degrees. Lovely. Okay. So there's 215 degrees. Now I'm going to go ahead and 215 is in quadrant 3. And then I'm finding the difference between this angle and my x-axis. And so my closest x-axis is 180 degrees. So 215 minus 180 degrees is, apparently I don't think I feel like thinking today, 35 degrees is my reference angle. All right, last one. Let's see if we can do it. So first I'm going to go ahead and convert it. And if I go through this one a little bit quickly, that's my bad. I'm just going to try and get this all done in one video. When I convert it, let's see, 17 times 180 divided by 6. So I get negative 510 degrees. Now negative 510 is too small, so I'm going to go ahead and add 360 to it a couple of times. I think I need to do it just twice. So negative 510 plus 360 twice, and I get 210 degrees. 210 degrees is over here in quadrant 3. The difference between 210 degrees and 180 degrees, remember, because I'm finding this difference between 210 and 180, is just 30 degrees. And then if we go ahead and convert that back to radians, since we started with radians, our answer should be in radians. 30 degrees times pi over 180 degrees. Let's see, 30 divided by 180, math, enter, enter, would be 1 pi over 6, so my reference angle is pi over 6. Beautiful. All right, let me know if you have any questions.